Okay, boys and girls, today we're looking at Module 4, Lesson 4, and it'll be very similar to yesterday's lesson. Yesterday we looked at the relationship between multiplication and addition. Today we're going to look at the relationship between division and subtraction. Okay? So right now on your desks you have a cup with squares for tape diagrams. Line them up and make a tape diagram of 20 squares. Okay, so you have your tape diagram, 20 squares across. The next step, divide the tape diagram into 4 equal sections. You might have to do some guess and check to see how many squares would belong in each section. We need 4 groups that have the same amount of squares in each one. So what number sentence would that be? How would we write that as a number sentence? Right. 20 divided by 4. And what is your quotient? How many were in each group? 5. Boys and girls, please listen. Now put your squares back together to make the tape diagram of 20. Take 4 away. We have 20 minus 4. Take 4 away. Now take 4 more away. So now we have 20 minus 4 minus 4. Are we done with our groups yet? No. Alright, let's take away another group of 4. 20 minus 4 minus 4 minus 4. Take away 4 more. You still have a group of 4? Take those away. Minus 4 minus 4 minus 4 minus 4 minus 4 equals 0. So now we have no squares left. 3, 2, 1. Nobody should be using the dry erase markers or the boards right now. You can put the squares back in the cup, and let's pay attention to the board, please. So what we did was we took our 20 and divided it into groups of 4. We kept taking away groups of 4. So when we did 20 divided by 4, we got 16, minus 4 was 12, minus 4 was 8, minus 4 was 4, minus 4 was 0. How many times did we take 4 away? How many times? 5 times. And what was our quotient? 5. So when we had 20 and we divided it by 4, take away 4, take away 4, take away 4. Every time we took away a group of 4, how many times did we take away groups of 4? 5 times. So the relationship between 20 divided by 4 equals 5, and 20 take away 4 5 times is the same. They both represent the same thing. So now let's look at a similar problem. We just did 20 divided by 4. Now let's do 20 divided by 5. Let's see if we keep taking away 5, if we get the quotient of 4. Let's see. So here's our number sentence. Minus 5, minus 5, minus 5, minus 5. What's 20 minus 5? Minus 5, minus 5, minus 5. So how many times did I take away 5? I took away 5 4 times. So my quotient is 4. So 20 divided by 5 equals 4. And 20 minus 5 4 times equals 0. Again, gentlemen, ladies, that represents the same thing. We have a relationship between division and subtraction. Will this work no matter what? 20 divided by 4 equals 5. 20 divided by 5 equals 4. Will it work? Well, we'll try it with x. If x was a number, 20 divided by x equals 5. What does that mean? Well, here's my whole value of 20. And I'm going to divide it into groups of x. I know that I need 5 groups because they already told me that. So I divided it into 5 groups. Each group is considered x. If I keep taking them away, 1, 2, 3, 4, 5. If I take away 5 groups, that was my quotient 5. So it will work no matter what set of numbers that we use. So whether you're looking at the quotient or whether you're looking at the divisor, it will work both ways, with the divisor or with the quotient. So now here, we took our quotient, we took our divisor and separated into the groups, knowing that each group equals 5. It's a little confusing with the pictures and the variables. We're going to try 2 different tables that are the same, whether we use the quotient or the divisor, and see what that works. See how that works. So let's just jump right in and try it. So take a look at your notes. There's a table on page 10. Okay? So looking on page 10, they did the first one for you. This time, we're dividing it by the groups of the divisor. So we have 12 minus x, and we took away x 4 times. So you draw your tape diagram that has 12 squares in it. Now, I need 4 equal groups. Again, you might have to do some guessing and checking to see how many go in each group. But I want 4 groups. Group, 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 group. So I made 4 groups. How many are in each group? 3. So that means if there's 3 in each group, 12 minus 3 minus 3 minus 3 minus 3 equals 0. So x equals 3. Let's try the next one together. 18 divided by x equals 3. Well, how am I going to start and write that out? How am I going to write that out? I start with what number? 18. And I'm going to subtract x how many times? Okay, so let's write that. You have 18, take away x 3 times. So now to draw your tape diagram, draw a tape diagram with 18 boxes. Just draw one big box, but cut it 17 slices. And leave room below so that you can write your new number sentence. So there's the tape diagram with 18 boxes. And I had to make 3 even groups. You might have to do some guessing and checking to see how many go in each group. Let's circle 3 even groups. Then we can count how many are in each group. 6. So instead of writing x's, now I can write the 6's. 18 take away 6, take away 6, take away 6. I took away 6 3 times. That left me with 0. So x equals 6. So try the next 2 on your own, and then we'll go over them. So let's go over the answers. We have 35, and we're going to take away groups of y, 5 of them. Whoops. Okay, so we have 5 groups of y being deducted. So our tape diagram is kind of obnoxious, but draw a tape diagram with 35 boxes. For your homework tonight, you have a table similar to this. If you could fit it in the table on the problem set, you could do it there. If you want loose leaf so you have more room, you could redo it on loose leaf.
Would I still have credit if I scaled it down?
You have to have 35 boxes, okay? Because that's the number that we have. You can't change the equation. You have to have 35 boxes. So I need to make 5 groups. So when I make my 5 groups, there's 7 in each group. So 35 minus 7 minus 7 minus 7 minus 7 equals 0. So y equals 7. There are 7 units in each group. (42) minus z, there are 6 z's. So I separated my tape diagram into 6 groups. There were 7 in each group, so I knew that it was 42 divided by 7. Z equals 7. I'm rewriting the number sentence below. Now what we did here was we looked at the divisor. We kept subtracting the divisor. If we take a look at the table below on your notes, they're the same division equations. This column is exactly the same, except we looked at the divisor to tell us the size of the unit. Now we're going to look at the quotients to help us. So our division equations are the same. So here the divisor indicated the size of the unit. Here the divisor is going to indicate the number of units. So the example, 12 divided by x equals 4. Well, let's take away groups of 4. How many times do I have to take away 4 to get my answer? So I took away 4, I took away 4, I took away 4. How many times did I take away 4? 3 times. So 3 is what x equals. And I can write my number sentence below. So try the next one. 18 divided by x equals 3. So keep subtracting 3. Let's see how many times we're going to subtract 3. How many times are we going to subtract 3 to get down to 0? So you have to do this mentally. Write this down. You're in the table below. Write this down. And then draw your tape diagram and circle off groups of 3. So as you circle off your groups of 3, how many groups do you have? Well, I had to take it away 6 times. So I have 6 groups. So that means x equals 6. Try the next two. So let's take a look at the answers. We have 35. We're subtracting groups of 5. So we could see that on the tape diagram. We have 35 boxes. I made groups of 5. How many groups of 5 are there? 7. There are 7 groups. So y equaled 7. 42, kept subtracting 6. How many groups of 6 are there? 7. So z equaled 7 because there were 7 groups. Every time I had to subtract 6 7 times. Yes. That's exactly what you have to do for homework. Turn the graphic organizer over. We're going to do the graphic organizer at the end. Okay, so if 12 divided by x equals 3, how many times would x have to be subtracted from 12 in order for the answer to be 0? How many times do we have to subtract x from 12 to be 0? What do you think? Well, you can figure it out mentally, too. How many times do we take it away? So 12 minus x minus x minus x. How many times, everybody? We have to subtract it 3 times. What is the value of x? 4. In this equation, 36 minus f minus f minus f minus f equals 0. Write a division sentence for that repeated subtraction. How would I write that as a division sentence? What do I have? What's the amount that I have? Everybody? I have 36. And what am I dividing it by? F. I'm dividing it by f. 36 divided by f. Oh, no. Yeah. Well, actually, the way they wanted 36 divided by 4 equals f. But I would also, because we have 4 groups of f. Like typically you would never see your variable as a quotient. I have a problem with that. You will never, ever, ever, rarely ever see your variable as a quotient. We didn't see that here. I'm actually thinking that's a typo in my book. That's the correct answer. I'm going against the teacher's now. That's what it is. So what is the value of f? What does f equal? What does f equal? 9. So if 24 divided by b equals 12, which number is being subtracted 12 times in order for the answer to be 0? What number is subtracted 12 times in order for it to be 0? 2. So 24 minus 2 minus 2 minus 2 minus 2 minus 2. We have to do that 12 times to get all the way down to 0. Alright, let's take a look. You're going to flip back in your page because they have your graphic organizer in a different spot. So let's take a look at this closing. Here we have a graphic organizer. Let's look at the relationship between all 4 operations. So let's put the addition symbol here in the upper right-hand corner. What is the inverse of addition?
Multiplication.
That's not they're related, but it's not the inverse. Remember, inverse means opposite. Subtraction. The inverse operation is subtraction. So let's put in the subtraction symbol. Today we discussed that repeated subtraction. So repeated subtraction is what operation? Division. And what's the inverse of division? Inverse meaning opposite. Multiplication. And what is repeated addition? Multiplication. So we can see how that all the different operations are related. Addition and subtraction are inverse. Multiplication and division are inverse. Multiplication is an example of repeated addition, and division is an example of repeated subtraction. And that's actually going to come in handy for tomorrow's lesson, the difference between repeated addition, and we're going to take that to the next step. So we'll see that more in tomorrow's lesson. Okay?